Good morning, friends. I thought that we must also discuss something on mode shapes. Before we talk about mode shape, let us try to understand what we are talking about. Let's say if I take a longitudinal case, then if I define this is the horizontal, this angle is theta, and if this is the relative velocity, then this is u, and this angle is alpha, right? If I give a disturbance to an airplane, I know the alpha will change, theta also will change. It is not only that how is their magnitude is changing relatively, that is important. It is also important whether their change is in phase or in out of phase. That is, when alpha is increasing, theta is also increasing, or when alpha is increasing, theta is decreasing. So we say they are out of phase, right? So we need to know that information from the dynamics, or we need to extract that information from the dynamics, and that will help us in designing the control, okay? In a very restricted manner, but very useful manner. We are talking about linear system, right? Now control has gone much beyond using linear approach or using transfer function approach. We will talk about state space modeling, so many things, but a good control designer knows he has to be very clear about the transfer function approach. A lot of information you get, okay? You understand, you could see physically, close your eyes, you could see, oh, this is happening, alpha is increasing, theta is increasing, what is the magnitude, what is the phase difference. So in a nutshell, we say when you talk about mode shapes, we talk about it is of interest, and you know why the interest is to find out the longitudinal motion variables, say u alpha theta, how they behave relative to each other. That is important. These are the motion variables. Remember, when we initially did the dynamic stability postulation, we have seen alpha s by delta E of s, theta s by delta E of s, E of s by delta E of s, and we have got expressions in frequency domain, and we address these ratios as transfer function. And what does it tell you? That if I have a aircraft system, this is a transfer function. If I give a delta E of s, I know what will be the output alpha of s, right? This is input output. Similarly, for this delta E of s, what will be theta of s? Similarly, what will be u of s? Right? This is typically longitudinal motion. But when we talk about mode shape, we are now trying to relate the relative changes between these any two variable u alpha or alpha theta or u theta in terms of magnitude and in terms of phase. And that is what we refer as mode shapes. Okay? This part is clear? How do I find out mode shape numerically? That is the question. Let us do that. When you try to find out the mode shape, we again go back to this equation, that matrix, remember? S minus xu into u of s. We have developed this minus x alpha u of s, then g sine theta 1, theta of s, then here it is minus zu, u of s, then it's a huge term, s u1 minus z alpha dot minus z alpha into alpha of s. This is alpha f, sorry, alpha of s. And then you have minus zq plus u1 s plus g. This is g cos theta 1. You have already these things, so don't blame me if I write something wrong. G sine theta 1, theta of s, and the third one is minus mu into u of s minus m alpha dot s plus m alpha into alpha of s. Then this is term is s square minus mq of s into theta of s. This is right. And we say when you try to find mode shape, the easiest way to do it is use free response. That is no external force. So this equal to 0, this equal to 0, this equal to 0. There is no forcing function. Now you know you are smart. What you have to find out is the relative ratios. You can easily see from here, you can write, although I say easily you can write, but you are seeing that I take help of this paper, somebody has done this for us. You should do, at your age I used to also derive this expression, but now I don't. And the understanding you can do yourself. So it will be something like this, s minus xu minus mu. Now our aim is to find out u of s by alpha of s. So it is very simple. I can again write this in terms of s minus xu. I divide it by theta of s if I am looking for theta of s. So there, this will again divide by theta of s. Here theta of s will go. So I am looking for u of s by theta of s. Then the second equation, what will happen is zu theta of s here, alpha s by theta of s, and here theta of s will go, and here u of s by theta of s, here alpha s, theta of s, and this will go. So what I am looking for, this relative values in terms of magnitude and phase for u of s, theta of s, alpha of s, theta of s, and that's all. Okay? And this you know how to solve. These are linear algebraic equation. And if you try to find out the expression, you can write u of s by theta of s like this. In some general form, I'm writing a1 s square plus b1 s plus c1 by a square plus bs plus c. Right? These are like algebraic equation. You have to solve this equation to find out u of s by theta of s. You can find out alpha s by theta of s. Okay? And let's say the generic form is this, where a1, b1, c1 will have some expression. Similarly, you can solve these three equations and find out alpha s by theta of s. And let's say that is given in terms of a2 s cube plus b2 s square plus c2s plus d2 by a square plus bs plus c. Right? And you could yourself check the expression here. A will be given as minus m alpha dot, B will be given as minus m alpha plus xu m alpha dot, C will be as xu m alpha or xu m alpha minus x alpha mu, and A1 will be minus x alpha B1 equal to m alpha dot g cos theta 1 plus x alpha mq, then C1 equal to m alpha g cos theta 1. Similarly, A2 equal to minus 1, B2 equal to mq plus xu, and C2 equal to minus xu mq, and D2 is equal to minus mu g cos theta 1. These I have taken from Roshcom. So to go further studies, you can refer that. Wonderfully, it has explained. One of the books I follow. But today's understanding, these are the equations you have to find these ratios by algebraically manipulating this. You can use a Cramer rule, whatever you want to do. By substitution, you can do. And these are for your convenience. I have given this. What is the message now? We are talking about mode shapes. That means we want to see the relative change in the magnitude and phase of the motion variables. For longitudinal case, it is u, alpha, and theta. Right? Remember, we have equation as4 plus bsq plus cs square plus ds plus e equal to 0. Say longitudinal case. Right? It has troubled us so much. It's a huge equation. But we also know for short periods, we had lambda 1 plus minus, say I say lambda 1, 2, minus for lambda short period, we have root, let's say a plus ib plus minus ib, and lambda 3, 4 for phugoid, let's say c plus minus id. Now, if you want to see the mode shape corresponding to short period, then what do you have to do? You have to put the value of s or lambda 1, lambda 2, which you have got from solving this equation, those value of s, which is a complex number, corresponding to short period root, whatever you have got, that you plug in here. Right? If you want to know alpha s by theta s for short period, again the value of s, what you have got, plug in here. A1, A2, A, B, C, all these things are known, depends on the mostly on mostly on dimensional stability derivatives. So once you do that, so you know how u of s and theta of s or alpha s and theta of s are varying for each mode, short period or a phugoid mode. Right? And after all, these are complex number. So you know complex number how to find magnitude and phase. That's our purpose. Just for completion, let me write the expression so that you can do yourself. I thought I must complete this. Nowadays we have MATLAB and all. You can directly compute these mode shapes once you give the values. Just to revise your understanding in complex number, complex number is represented by this, and if I have a ratio of alpha s by, let's say, u of s as n numerator plus j omega numerator by n denominator plus j omega denominator, suppose the complex number is having this sort of a form, then I know the magnitude will be given as n numerator square plus omega numerator w, don't say omega w numerator square by n denominator square by w denominator square, and the phase angle is given as arc tan Wn by Nn minus arc tan Wd by Nd, the Nd, the tan inverse. Okay. It is so straightforward. So let us again revisit how do I find this phase difference or magnitude to understand the mode shape of motion variable alpha, theta and u. What do? We take the characteristic equation, right? Then divide by theta of s and alpha of theta of s. Then we from here I can find out u of s, expression for u of s and by theta of s and alpha s by theta of s, which will come as ratio of two complex number. And we know if this is the two ratio of two complex number, how do I find magnitude and phase angle? Right? It is as simple as that. If I want to find out the mode shape for short period mode, so in the expression of alpha s and u of s, which had s, if you see the earlier expressions, you have to only put the roots corresponding to short period. For Fugger, you have to put the value of s corresponding to Fugger, right? And you will get ratio of two complex number, and you can find magnitude and phase angle. And from there, you could see that for that disturbance, which motion variable is predominantly changing and which is not changing, and among or between the two, what is their phase difference, right? Okay. So this is the background for mode shapes. Thank you very much.